Hello viewers, in this video we are going to derive the half-life formula for a zero order chain correction. So what is this half-life that we are talking about? Now when we talk about half-life, we're talking about the time it will take for half of the initial amount to be used. So for example, if we are starting with the concentration of 20 molar, so we have 20 molar concentration initially. The time it will take for this concentration to change to 10 molar, which is half the initial amount, this is what we call its half-life. So half-life is just time taken for half of the initial amount to be used. All right. So how do we derive this? We derive it from the integrated rate law for a zero order reaction. So let's do that. So the integrated rate law for a zero order is given by the final concentration is equal to minus Kt added to the initial concentration, like that. So this is the integrated rate law for a zero order reaction. Since we are looking for time, we are going to make the Kt the subject of the formula. Since this Kt is holding a negative sign and we want it to be positive, we're going to take it on the left side so that it becomes positive, and then we're going to take the final concentration on the right side, like that. So let's quickly do that. So what we'll have now is Kt is equal to the initial concentration that we have here minus the final concentration, because when the final concentration crosses the equal sign, it will be a negative. So we'll have minus the final concentration. After doing that, we're going to continue and say Kt. Now, this Kt, we're now introducing half-life. Kt half, like that, is equal to the concentration of A initially. Now, when you introduce this part here, this makes the T to be half-life. So T half represents half-life. Now, at half-life, what we should know is, let's say at half-life, on the other side, at half-life, we're going to have the final concentration to be equal to the initial concentration divided by 2, or half the initial concentration. So at half-life, the final concentration will basically be the initial concentration divided by 2. So that's what we are going to have. So this is final concentration, which is equal to initial concentration divided by 2. So that's what we are going to replace where there is final concentration. We are going to replace by the initial concentration divided by 2, like that. So that's what we have at half-life. We can see we have introduced T half. The T half means half-life, and then this will be equal to the initial concentration minus the final concentration. But at half-life, the final concentration will be equal to the initial concentration divided by 2. I hope that's clear. Then we'll proceed. This will be equal to our Kt half, like that, is equal to, we'll still have our initial concentration there. Now, working on what is on the right side, what we are going to have is this. So this is over 2, and this is like over 1, so it's over 1. We're going to find the common denominator, like that. So let's say we have a common denominator here. This is 2 and 1, so our common denominator is 2. 1, this one will go twice here, multiplying that 2 by the concentration we have there. What we are going to have is, we'll have 2 multiplied by the initial concentration, like that. And then this will be subtracted by 2 into 2 will go once, multiplied by the concentration. We'll just have the concentration, like that. So this is what we have on this side here. So we'll continue to say we have Kt half is equal to that which we have there. Now, this will make us have our KT 1 over 2 to be equal to. Now, when we say this 2 initial concentration minus the initial concentration, this will just give us, this is the same as 2 minus 1, and that will give us just 1. So what we'll have there is, we'll just have the initial concentration on top here, like that. And then this will divide by 2, like that. Yes. So when we reach that stage now, we are going to make half-life the subject of the formula. This T half is half-life. K is the rate constant. So we want to make T half the subject of the formula. What we are going to do is we'll just multiply the whole expression by 1 over K. So what we are doing is we'll multiply this whole expression here by 1 over K, like that. When we do that, this K here and that K will cancel. So those will cancel, and what we are going to have is we'll have our T half is equal to, on the other side, we'll have the A initial, which is the initial concentration, divided by 2. And this was to multiply by 1 over K in that case, just to make sure we understand. So this is T half is equal to, now when you multiply the initial concentration over 2 by 1 over K, this will just give us the initial concentration on top there, divided by 2, and this 2 is multiplying by K. So this is what we are going to have. But the initial concentration here is multiplying by 1, and then 2 is multiplying by K. So we'll have this by that, giving us the initial concentration on top, then 2 by K, giving us 2K down there. So this is the half-life formula for a zero-order chemical reaction. So this is how we derive it.